Our IoT project consists of a smart restaurant platform for both customers and owners, capable of monitoring the comfort inside the restaurant and displaying orders and bookings performed by clients through Telegram. The architecture of our project is described here. The catalog stores information about the configuration of different actors, from the base URLs to the tokens to use. Instead, all the information related to single users of our service is stored in an online database hosted by Google, called Firebase. Telegram is exploited to create an automatic chatbot that is used to create an interaction with a single user who wants to make a reservation to a restaurant. The Thingsboard is used as the IoT platform of our project and dashboard of the owner of a restaurant. Here the info of the real and simulated sensor are displayed, and the different table and delivery orders are described. Finally, a web application is built using the Django framework, which creates 3 different interfaces, 2 for the client and 1 for the owner. Let's now present the web platform for the owners. Once landed on the main page of our platform, the owner will have to create an account for the restaurant, filling in the fields with all the details necessary and submitting by clicking the proper button. On the right hand side, the Heroku console is shown. It is the platform as a service we use to deploy our system. All the requests performed by user interactions are printed in the console. For example, CSS, JavaScript and images are loaded through an HTTP GET request. As you can see, many fields are present like contact info, number of tables and opening hours. Once the restaurant is submitted through an HTTP POST request, the account is added on Firebase in real time and the entity is created in the Thingsboard's relational database. From the Firebase console, the information is stored in a JSON-like structure, and each restaurant is associated with a randomly generated unique identifier. One of the fundamental functions is the possibility to create and populate the menu. In here we can see how easy it is, and that besides information related to the dish, it is possible to add a photo of it, always stored in the Firebase and reachable through a link located in the details of the newly added item. The link redirects to the resource located in the Firebase storage, used to store all images of dishes for each restaurant. However, if something goes wrong, there is no need to panic. It is always possible to remove the item by simply clicking on the Remove button. From the point of view of the owner, orders are managed through a simple interface, summarizing all the details such as if it is delivery or table service, the total amount, and so on. Obviously, the owner has the possibility to update orders statuses thanks to the drop-down menu, choosing among accepted, preparing, delivering, and completed. Furthermore, through the control panel, it is possible to see table and delivery orders. By clicking on any table, requests through Telegram app will be displayed, and the owner will be capable of signaling the table as reserved or not manually. As regards sensors, we simulated temperature, humidity and motion sensors, all for each restaurant, and in order to have them working almost in real time, we use threads. As you can see on the left hand side of the screen, each thread is responsible for a different restaurant. The simulated data are uploaded on the dashboard using MQTT protocol. Since this is the control panel for the restaurant previously created, looking at data generated every 5 seconds, we can see that both temperature and humidity data matches with data read from dashboard. The gas readings instead are not simulated. A real sensor sends data through MQTT protocol and their values are shown on the bottom right window. Concerning the user feedbacks, thanks to the Telegram button, it is possible to signal a too low or too high temperature. If some feedbacks are read in a short time, this indicates that many users are feeling discomfort. The number of feedbacks, however, can be changed by the owner thanks to the specific window. An alarm will appear on the right side of the dashboard if this happens. business. In such a way, to have a scalable product that could deal with IoT devices like smart HVAC, a button to activate and deactivate HVAC system is located in the middle of the dashboard. To assess its working, this is linked to a simple LED that will turn on and off whenever the button is pressed. In a similar way to what happened with the registration of the restaurant, also a client can sign up easily on our platform. Clearly, the information required will be different but performed with a post request in the same way. Data inserted by the client match with the ones stored on the Firebase database, and it is important to notice that once the user is logged in, and this is valid for both clients and owners, session data are used to track its activity and information recently added, in order to populate part of the interface. If the user is performing a delivery order through our web platform, in the dedicated section Restaurants, he can select among the ones that had joined OrderEat system. Through an interactive menu, clients can select quantity of a dish and fill the cart. In the same way, users can remove unwanted dishes from it. Once the order is completed, users insert the delivery address and perform the checkout. Each addition and removal is performed with an HTTP request, updating the last basket field of the user present in Firebase. Once the checkout is performed, last basket is stored in the orders database with a smart key value relationship. Whenever the user is logged out or changes the restaurant, last basket is deleted. We now present the Telegram platform for the clients. Here we can see the split screen with Telegram app, Firebase database and Windows console. Registration procedure is much like as the one in the web platform, requiring same information from users to create same entry on Firebase. The procedure is performed interacting with a chatbot using a staged environment with the addition of simple button keyboard to help the customer finishing the process. We can see that simultaneously a new entry on user database is created through a post request on Firebase. Now it is possible to see how the client can perform a reservation. Information needed is the restaurant in which user wants to book a table, number of people, and the time, which is asked through a keyboard automatically created from restaurant opening hours. At the end, an automatic check is performed to assess if the table is available. If so, through post requests, customer entry in user database is updated. This is repeated on restaurants customers entry. In the same database, the field bookings is filled with an object that is used for checking the availability and for connecting with the Thingsboard dashboard through the table ID. After the booking procedure, the user can place an order in the system exploiting a unique URL generated by combining user and restaurant keys. This link will redirect user to a responsive web page belonging to the TG menu application of Django. As you can see, the customer can select dishes from the menu and add them to the cart, in a similar way described for delivery orders. By clicking the checkout button, order is stored in the dedicated database, listing the requested items and details. From the point of view of the owner, dashboard is now shown. Orders are listed in the table assigned to the client with the items selected. Finally, the user can complete the ordering process by requiring the checkout. By doing so, the active field from customer is deleted, as well as the active field on restaurant database. This will update status on the table on Thingsboard dashboard. Besides the possibility of retrieving sensory information, clients can provide feedbacks about their comfort to modify the room temperature. This info, as described previously, is sent to Thingsboard's dashboard and shown in the console.